Hi, my name is Stone ID, and today I will go over my second part of my Lua tutorial. And basically, you can use Lua for much stuff, and it happens that Heroes of News is using Lua for bots and interface code. It has been added recently, I think about a year ago, and since then the interface code has been slowly replaced with Lua code. And now we have bots, and this is why we will do this tutorial. I will try to keep it simple, and I will simplify some things because of that. So don't be confused if I'm not going into the technical details too much, but I might do that anyway, so yeah. I will try to keep this on a beginner standard, so if you haven't programmed before, you should be able to understand what I'm telling you. And I would, yeah, let's just go ahead with it. So I have this file set up, and I will go with line by line. And let's just start with this. Let's just start with the comments here. As you can see, there are two dashes, and those two dashes tell the interpreter, the Lua interpreter, that the all the text on the right side is to ignore. So this green text wouldn't and will not affect your code. And you should use that to comment more complicated code or to describe what certain functions are about. And yeah, we will go over what functions are later. So just be advised that comments are a great thing to keep your code readers informed of what you have been doing in your file. And as you can see, I've been doing this a lot. There's lots of green text in here, because you can't be too unspecific about stuff. You can't just too be specific, right? So yeah, these are comments, and there's actually another way to write them. You can do two dashes and two of those brackets, and to close the comment you do the other brackets. And what this does, it allows you to write a comment here, and here, and also here. So you can write multiple lines of comments if you use the brackets. Of course, you could also do this like this to save some space. But yeah, it's mostly a design decision, and it doesn't affect the interpretation of the code at all. The next thing, we have variables in each programming language. So if you're new to programming, a variable is basically a container to keep certain kind of information inside it. There are different types of information you can store this. There's this Boolean information, and a Boolean information is just something true or false. You can't do anything else. With a Boolean, you have these numbers, obviously. You can also use 0.4 or whatever. By using a full stop, you can do decimals basically. And you have strings, which are those two. And strings are just text. It's as easy as that. So let's start on the top. Booleans are used in multiple ways, mostly in expressions and stuff, to keep track of certain abilities, of certain conditions bot might have, or anything might have. And yeah, there's no magic about it. And as you can see, all these variables have a local tag in front of them. And this local tag, to keep it simple, just tells the interpreter that these variables can only be accessed by this file. So whenever I would try to access this variable by another Lua file, it wouldn't know this variable. It can't see it. Imagine you would have a box with all the variables in it, which is this file, and as they are marked as local, other boxes can't look at the variables unless you have you don't have the local tag. The box would display it through some kind of window to the other boxes, just to make it a bit more graphical here. And yeah, we will keep the local tag just for logical reasons. And yeah, so there's nothing special about numbers. As I have told you, you can do decimals by using a full stop. A commenter won't work, as you can also see on the coloring. The full stop is actually orange in the highlighting. Then you have strings, and for strings there are two ways to define them. You can either use this apostrophes to open and close the string. Be advised that those are not part of the string, they're just telling the Lua engine where the string starts and stops. So everything in between will be the string, in this case hero, but those won't be. The same goes for those quotation marks. They just limit the inside of a string. So where's the huge difference? The huge difference is that you can use an apostrophe inside a quotation mark. And you can use a quotation mark inside of apostrophes without breaking the concept of the string. However, if I try to change the string, let's just do that. And write, he's a good guy. So you will see on the highlighting that Lua actually thinks, oh wait, the string stops here. To avoid this problem, you can use quotation marks as an easy fix for this. The same thing goes for, oh, I want to use quotation marks, but I don't need apostrophes, so I might just use apostrophes to limit my string, to define my string. So there might be the case that you actually need both of these signs inside a string. So let's assume I would need a quotation mark here. As you can see, it breaks my string, but what I can do is I can use this sign, and I'm not entirely sure how it's called. It's a backslash, I think. So if you use a backslash, the backslash won't appear in your string once you display it. It just marks the sign beside it, yeah, as a special character. A character is one single letter. But don't be confused by this. Just be advised that you can use backslash to comment out those string instead of actually limiting the string. And you can do the same. Oops. You can do the same with what I'm doing. And you can do the same with backslash and apostrophe, and you can use apostrophes inside an apostrophe defined string. There's nothing complicated about that. There are also other comments you could give with strings. You can do a line break with this, but yeah, and this might be too much detail for the beginning, so just be advised that you can define strings like that. And as I haven't said it yet, this is the name of a variable. You can choose whatever you want as the name for your variable, but be advised it should be descriptive. So I have chosen be alive, and I've chosen an health, and we had a simple design decision to have those prefixes. So for all booleans, we use a b, a small b, before the actual name, and for all numeric and for all numbers we use n, and for all strings we use an s in front of them as a prefix. So if you go over your code later and you might have stopped working on it for 2 weeks or something, you can instantly see which type of variable you actually have. So the name has actual no real influence on how the variable works, but you should try to keep it on a level that you can easily identify the type and the purpose of the variable. So be a bit careful about naming your stuff. As you can see, our next topic is basic math stuff. So I've defined 2 numbers here, and to keep it simple I just named them A, B, C, D, E, F, and didn't do any prefixes and stuff, just to keep it simple. So yeah, we have defined A as 10 and we have defined B as 2, and now we're doing some basic math operations. C is defined as A divided by 2, by B, excuse me, which is 10 divided by 2. So our result would be 5, and C would actually be assigned the number 5. Bitwise, this is actually bad coding practice. If you want to assign 5 to a value, just assign 5 to a value. Yeah? There's no need to divide stuff or multiply stuff or whatever if you actually just needed a fixed number. Yeah, well, just go on. The star here means multiplying, so A multiplied by B, 10 multiplied by 2, is actually 20. And I've written this as comment here. As I said before, the comment has no functional meaning to the code, but I tried to visualize the results of these equations. The next thing, E, is defined by a subtraction. So A minus B, 10 minus 2, is 8. And of course the addition for F, A plus B, 10 plus 2, is 12. So F is 12. Yeah, this is the basic thing. One little note on the side here. If you want to divide stuff, be advised that dividing is actually more performance costly than multiplying stuff, by far. So if you have B fixed and B won't ever change in your code, so actually you could write 2 here because you don't need to change B. Be advised that it's way faster, instead of dividing by 2, to multiply with 0.5. And yeah, this is just a little performance issue, and whenever possible you should try to multiply instead of dividing. However, don't be too confused by this fact. And let's just go on with it. More math. This is actually not defining of a variable right here. This is the changing of a variable we have. So as you've seen before, if we type any name and assign a value to it or an equation to it, it will assign to the variable name the value we have defined on the right side of the equal sign. And this is exactly the same thing happening here. And while this would be, at least in school math, total nonsense, it actually has a functionality here. Because here the code looks up what is A and what will I do with it. and it looks up. Oh, a should be a plus 1. So at the moment the code is executed. It looks up a, which is 10, and adds 1 to it, which will result in 11, and then it will store the 11 in the inside of a. So we actually increase a by 1 in this line. And the same thing happens here. What should I do with a? Oh, I should multiply the value a half for a with b. So as we did increase the number of a in the line above, and it's now 11, we multiply with b, which is 2, and we will have 22 as a value here. And so the 22 will be assigned to a, and a is now 22. A little side notice for those guys of you who haven't, who have done programming before, might have done C#, for example. You might be used to write it like this: a plus equals 1. Be advised that this won't work. I'm just showing this to prevent errors, and this will not work. This syntax is not valid in Lua. If you want to do this operation like you used it, you have to do it like this. The same goes for multiplying, dividing, and whatever. So increasing a number by 1, this is the easiest way to do it. So let's go on with some magic. Functions. Functions are a tricky thing, and I will try to explain it as well as I can. So a program always goes from top to bottom, so it runs from top to bottom, line for line. The interpreter will go over the file and try to execute whatever you tell him to do. Now, a function is actually a variable. You can't really see that. You can't really see that, but the function will not be executed once you write them. To execute a function, you have to write hello world and these brackets, and what happens here is the interpreter runs over this code, sees, oh, this is a function. So the function hello world, the variable hello world, basically gets this code assigned to it. Don't be confused, gentlemen. And the end tag symbolizes that the function ends here. So the interpreter goes to the next line, and he will see the hello world execution command. So what this will do, it will look up the hello world function, which we have defined here, and it has to be defined above, and it will say, hey, yeah, we have this function, let's do whatever is inside of it. What's inside of it is this print command and a comment. Yeah. What print will do, it will display whatever string you give to it inside the console of Hun. And so this will actually print hello world, and I've written this as a comment here because this is our result, and we will see this actually inside the console of Heroes of News. So yeah, let's go on with it. The next thing are functions with arguments. So again, this function called print something has an argument it can handle, and the argument is called something, and it will try to print something once you call the method, the function. So here's the definition of the function. It ends here, and the Lua code comes to this line. The Lua interpreter comes to this line and sees, oh, he wants to execute print something. But if you compare it to here we just have the brackets, and here we actually have a string inside the bracket. And this string is passed to the function, and it will execute this code, but the something will now have the value, the string assigned to it we've defined here. So I print something is now the value of the variable something, basically. And print will display I print something inside the console. So you can also pass multiple arguments to a function, and you can do this by adding a commenter and doing any other name, like let's call it other. And if you pass other and do some fancy stuff with it, what could we do? We could print. Let's do a second print command, and the second print command should actually print other. So we have no second argument defined here, which should be passed to the function, and I can do that by simply adding a comma and writing any other string and it will print both strings after each other. Yeah, this is the basic concept of having multiple arguments for one function. And I wanted to show that you can actually do some other stuff with functions. Let me just look at my cheat sheet here. Oh yeah, right. I wanted to show you something more, a bit more about this. So let's delete that. I can define another local variable inside my function. Let's just do some random number here. And I have called it distance and distance. And yeah, what this does, it creates this variable inside the function boundaries. You won't be able to access this variable outside the function. So if I try to do some math operations like a equals and distance, this won't work. And distance is only visible to the function itself, as it's defined as local. And I think the Lua interpreter will also throw you an error if you try to do it without local and haven't defined this variable before. So A has to see the variable, and as I said before, the local tag can be imagined as storing something inside a box, and each function is basically another box, and what's inside those function boxes can't be seen by the box above. So those are little boxes inside one big box, but the big box can't see the inside. And this is basically what this local tag says. That was a bit confusing, wasn't it? So let's move this. And we will delete that because this is wrong. This is just plainly wrong. Let's move this to here in the function above. So we have the local and distance, which is defined as 5502, and we want to print this with the string here. What we can do is writing 2 full stops and then and distance. And what happens now is, the moment the interpreter reaches this line, it says, hey, I have to print hello world and distance attached to it. So this would print hello world 5502. So this is a bit ugly. Let's do a space here, and this will be our result. So 2 full stops concate whatever variables are inside this command. This works for strings, this works for numbers. So if and distance would actually be a string, we should also change this prefix. Then our result would be, of course, be hello world hello. And this bit useless, but imagine you would do this inside this function. You could combine 2 strings, 2 different variable strings, into one printed result. So just an idea here. And actually I will change this back to a number to display a bit how flexible you are here, and also to match my cheat sheet I have on the right side outside of the recording screen, and I don't get too confused while doing this tutorial. So yeah, I wanted to go ahead and do another call here. I can do print something and call it with another argument, and this time I will use as description. As description here. Here we go. And as description is a variable, and we have defined this already. As you can see here, we have as the variable as description, and its value is this isn't a hero. So what will happen is this line looks up as description, and if it finds it, it takes the value of as description, which is this isn't a hero, pass it to print something, and print something will be executed and print this isn't a hero. So yeah, I think this should be understandable. At least I hope so. If not, make a comment and I will try to explain it a bit better the next time. Yeah, let's just head over to the next function I've created. And this function I've called exponent because it exponents a number. And as you can see, it takes its argument called nGiven, multiplies it with itself, and stores this inside n result. And then it will return a result. And let's just go over this in detail. So you can see here my exponent call, and I've passed 3 to it. So if we assume this nGiven is now 3, and 3 by 3 is of course 9, and n result will be 9 right now. But we don't have a print or anything right here. And yeah, this function doesn't seem to do anything valid to display. It does not display anything or change anything. It just executes a 3 by 3 multiplication in this case. But it returns the 9, the result. And what this allows us to do is assigning a variable to this expression of the function call. So the result of this function will be returned and passed to the left side. So G calls the function basically. The function calculates, oh, the result is 9, and tells G, you are 9 now. To make this a bit more visual, we could also do print here, write exponent 3 and close it. Now let's just do some spaces here so you can see it a bit better. So print will call exponent, exponent will calculate 3 by 3, like we can see here, return it to us, and print will get the result 9 and will try to print it. So I think we can't print single numbers. I'm not sure, to be honest. So we could do just result and use 2 full stops to concate those two. And our print function would give us the would display us inside the console result 9. So this would be our displayed result, our final result. Yeah. And we can also do this exponent D. And it's a bit confusing. No, it isn't. We have done this before. D is actually defined already, and as you can see, D is defined by 20. So 20 will be passed to exponent. Exponent calculates 20 by 20, which is 400, returns it, and the returned value will be assigned to H. And H will be 400 now. Not that complicated. So, right, other stuff about functions. As I stated before, a function is basically a variable. And to show this a bit better, you can actually define a function like this. And I've called this function exponent2 because it's exactly the same thing as exponent. It's just defined in another way. So this line is actually exactly the same thing as this line, with the difference being that this function is called exponent2 and this one is called exponent. And that's all. Also, I've got rid of n result and said return n given multiplied by n given. So it will just multiply the same way as it did before and return it. So this is actually a neat way to save some space in your files. And I'm thirsty and I will drink something. It's good tea. Excuse me. So let me just look a bit. Yeah, I think we're fine. So the next thing, tables. Tables are containers again, and tables, you could call them lists. They are a list of elements, and you can store stuff inside of a table. And you can do this. You can define a table like this. You give it a name, make an equal sign, and then you just do those brackets. And this will give you an empty table or so to speak an empty list. Two numbers, like seen here, is defined a bit differently. It's not empty. It has some variables inside of it, and yeah, how to explain it? You separate different elements of a table, different contents of a table, with a commenter. So the first entry in our list or our table will be 1. The second entry is a 2. The third entry is 44. The fourth entry is 22. So yeah, I think that's very clear. T mixed is showing us that we actually can mix up the kind of information we want to store in our table. So we have a string here, we have a number, we have a boolean, and we even have a function and a variable we have defined before. So I think I have to go a bit into technical detail here. Hello is just defined here, as is 3 and as is true, and those will be stored in the table just like they appear here. H, however, will of course look up to the original H definition, which is here, and as we have been mentioned before, 400 is the value of the variable H, and 400 will now be stored in this place of the table. So I've also written exponent here, and there's a little detail you have to be aware of. As functions are actually some kind of variable, you can store functions in a table. So if we access this later, it will actually access the function and not a value or something like that. It's difficult to explain, excuse me. I could change this. So for example, if I do exponent 3, and we have done this before, exponent 3 is actually 9, the table will store 9 here. So the number 9 will be assigned here. But if we do not have the brackets with an argument, it will store the function itself inside the table. So let's just do some practical stuff here to understand it a bit better. We have our well-known print command here, and we have written tmixed with brackets and a 1 inside of it. And what this does is it looks inside the table tmixed on the first position as defined here and print it. And we all know that the first thing is hello. We have defined it just a line above, and it will print hello. So the result of this line will be hello as a display in the console. The next line combines this a bit better. It's tmixed. It looks inside this table on the second place, which is 3, and then adds the fourth place of the table to it, and the fourth place is H, and as we said before, H is 400. So our interpreter would add 3 to 400, which is 403, and print it to the console. So it's really just look up this position which is given inside the brackets and print it, and in this case just add it. This is a basic math operations combined with looking up a table. And here we're going into cryptic stuff. The way to read this might be a bit complicated at first, but you will get used to it. And what this does is it looks up t-mixed in the 5th position, which is exponent, the function itself, not a result of the function itself. So basically we just execute exponent here in this case. And we pass with these brackets, which are now red, with these brackets we pass an argument to exponent. And the argument we pass is the 2nd position of t-mixed. And the 2nd position of t-mixed is 3. So basically we call our exponent function and pass 3 to it. And this will of course return 9 again. But with no functional use, as I've just discovered myself. So let's just wrap this in a print. So this would actually print out 9 and has no functional difference to this line, at least to this part of the line. Yeah, but the huge difference is actually that we looked this up from a table, and we could change the table in any at any moment of this program. We could change the table. Therefore, changing this function, then this line would print something completely different as we swap the functions. But this is just this is a bit far-reached, I guess. Yeah. So I've assigned keys to table elements. Yeah, what does that mean, right? We have this empty table here called t_enemy, and t_enemy has no elements inside of it. And let's just go up here again. Those two tables have 4 elements in this case, or 5 elements in this case, and you can access them by numbers. However, those numbers are actually keys. So you have to imagine it like key 1 is 1, key 2 is 2, key 3 is 44, and key 4 has the value 22. So it just numbers all the different values we enter automatically. The same happens here. 1 is hello, 2 is basically 3, and so on. You can't see that, but it is happening. But what you also could do is say t_enemy should now have a key called name. So the key name will be assigned the value creep. We'll have this value, this string called creep to it. Okay, this was grammatical completely wrong, but hey, who cares? Yeah, so t_enemy has now an element called name, and this element name has the value creep. So it's basically a variable called name inside a table, and the variable has the value creep, a string. And we could also do this like we did here, which is t_enemy point full stop health equals 243. Just to display this, bit better if I do tEnemyName creep and get rid of this line, we would achieve exactly the same. So just to bring it back, those two lines here are functionality exactly the same. It's really just a design decision how you like to write stuff. Yeah, it's really just, hey, how do you like to code? It's nothing more. So we can define table elements with keys like using this way, and we can also request them this way. So if we want to print an element of tEnemy and we want to print the element name, the following thing will happen. We have written tEnemy name. So it will look into the table tEnemy, search for the key name, and print its value. So the value of tName is creep, and therefore we will have creep displayed in our console. And as I said before, you can define them in two different ways, but you can also request them in two different ways. And it doesn't actually matter how the variable inside a table is defined, how a key is defined. You can request them however you want. So both of those lines will print creep in our console, because here we look into our table, search for the key called name, and print its value, which is creep. And now a conclusion of all those things I've said today. We have print something, which is a function we've defined before, if you remember. As you can see, it's just a simple print call. And we pass an argument inside the brackets, which is tEnemyName. So we look into the table tEnemy, look for the key called name, we get its value, which is called creep, pass it to print something, and print something will now have our string creep and print it. And that's all. So these are how functions work basically. So sorry guys, I had to cut the video because there went something wrong, but don't worry, the file is fine and I haven't changed the file in this cut. Anyways, I just wanted to show you that you can run your code from this tutorial online on the Lua webpage. And for this I went to Google, and if I type in Lua demo and use the first result, I'm coming to the Lua demo page. This allows us to, not cut, to copy our file. Let me just do it like this. Okay, copy our file, paste it here. As you can see, I now have the code in my little text box here. I can run it. And we will get the output of our program. So all the print commands that have been executed while this program ran are now shown here. You can see it works with numbers only, it works with our addition stuff. We have our 3 creep lines. Let me just extend this and scroll down. Now we can compare it to our program. Let's see. Yeah, you still can see it. So I think I had this a bit bigger. And yeah, well, let's just start on the top of each of them. It's Hello World 5502. As you can see, this is this function call. We called our function. It created the variable and distance. concatenated the string hello world with the distance, and this is exactly what we got here, and also what I predicted in my comment. That, yeah, what I predicted in my comment. End of story. And we have our result colon and our 9. This is here. This isn't a hero, and I print something. Or here, I print something, call to the function as description, which was this isn't a hero, passed to the function print something and got printed. So everything went as expected, and you're free to examine this on your own and mess with the different types of variables you've learned today. And yeah, I hope you liked the tutorial, and I hope you're there for the next part, where we will go over loops and if cases and all this stuff, so you can do more interactive programs and actually do something on certain conditions. Yeah, until then, I hope you liked the tutorial,